Hello everyone, my name is Ram Vendatram. In one of my previous sessions, we discussed about microservices. Microservices are small individual autonomous software block which has a definitive objective, right? So if you want to build your application using microservices architecture, how you will be able to accomplish that, the sense how you will be able to implement those microservices blocks, and how you will be able to manage multiple microservices block. So that's it, agenda for today's topic, right? So I'll just list them down. So number one, we are going to discuss about containers. Number two, Kubernetes. Number three, serverless architecture. So serverless architecture is slightly different, but I'll be able to compare containers and serverless architecture, and when you have to go for containers, and when you will be able to go for serverless architecture. So that is the agenda for today's discussion. Okay, let's jump into the discussion. Number one, containers. What are containers? Containers, as the name implies, it contains things that are required for microservices to run. So when I mention things, it includes the code, that is the application code, and runtime environment, and whatever the system libraries that you need, and the system tools that you need to run to execute microservices, and any other settings that you will need. So everything will be put together inside the container, so that it will be given as a package, and it will be executed in any OS that you would like to execute your microservices project. So that is container. So there are different types of containers available existing in the market, and one of the famous containers is Dockers. Dockers containers is a very hot topic at this point of time. So what is that relationship between containers and the Dockers? Containers and Dockers, if I can take an analogy from object-oriented programming, you have class and you have object, and the object is derived from class. I mean, the object is instantiated from class. The very same relationship is shared between containers and Dockers. So Dockers are nothing but the images, that is the template that, as I mentioned, you it will have code, runtime environment, and any other settings that you will need, and system libraries and tools that are needed to execute that microservices application will be there in Dockers, and you will put together, and you will just place that inside the operating system, and everything else will be done by Dockers. So easy, right? So if that is the case, then what is the difference between a VM and container, right? So you must be aware of virtual machines, that when you go for cloud computing, right, you can buy virtual machine VMs, and everything will be there, and you can just go and deploy your application, and your application will run from those VMs that you purchased from clouds. So what is the difference between VMs and these containers? Well, the VMs has operating systems bundled within it, and the container doesn't bundle operating system. So that's a major difference. So in case of containers, all the containers that are implemented inside the machine will share the same operating system. That is, will share the same host operating system. Whereas in terms of virtual machine, uh, the host itself will be, I mean, it will not be called as host, right? I mean, the guest operating system will also be part of that package, and it will be executed in the virtual machine. So that's a major difference. So, and in case of, I mean, since operating system is sitting outside the containers, the Dockers is the one which will mediate between the containers, that is that runtime executables and the operating system. So whatever the operating system needs from that runtime execution, the doctors will get it from the programs and pass it on to operating system. So that is the work that is carried out by in between layer of doctors. So that's a major difference between Dockers and I mean containers and virtual machines. I mean basically containers are the improvised version of virtual machine. I mean virtual machine we had it a few years before, like 5 6 years before. Then it got improvised, and now we got into this containers. Containers are much cheaper as compared to virtual machines as well. So I just wanted to point out the difference between containers and virtual machines. And I'm slightly moving on, right? The second topic in my list is Kubernetes. Once you have created your containers, right? If you want to build a reasonable sized application, you may probably have 15 to 20 different containers. So how are you going to manage the implementation of all the 15 to 20 containers, and how will it scale up and down? So you need to have a integrator or orchestrator, right? I mean, a centrally managed orchestrator. Otherwise, managing containers will become a overhead, and that will become a drawback for using containers. So to avoid that, we have one mechanism called orchestrator, container orchestrator, which there are multiple options available, and the most famous one at this point of time is Kubernetes, right? So we will have a quick touch on Kubernetes. What is Kubernetes? Kubernetes has a multiple something called nodes in it, and there will be multiple nodes within one Kubernetes, and these nodes will hold all these containers. So one node will have more than one container, and this Kubernetes will also have a service request like which node, which container which is there inside the node will get implemented at what time on what machine. So all these requests will be given to Kubernetes, and these Kubernetes will do this orchestration of running and executing these container blocks. So without orchestration, without Kubernetes orchestration, it's still possible to execute it with containers, but it will be a lot of work, and finally we will mess up the entire implementation. So it is better to go for Kubernetes. There are multiple options available for this orchestration, like you have something called service fabrics, and which is given by Azure, and there is something called Docker Compose. So there are multiple such orchestrators available, and based on the necessity, I mean, every orchestrator will have a different technical requirement. Based on your particular requirement, you may have to go for it. But Kubernetes will fit in most of the bills. That is what my experience says. So that is what Kubernetes is all about. I mean, crux of Kubernetes, right? The next topic in my list is serverless architecture. So it is slightly different from container and its orchestration, but I have just given it so that it will gel together when we want to design cloud first applications. So what is serverless architecture? So you build your application, right? And you have you want to run this application from cloud. This serverless architecture is applicable only for those applications which run from cloud. It cannot be done from your on-prem to your own servers, right? So that's a basic prerequisite for having serverless. So now you have built your own application, and whenever you go for implementing those servers in cloud environment, right? You need to have your servers procured, and design, and everything has to be available. That is virtual machines, right? So, and once that is available, you can just go and implement that. And what if those applications will get executed maybe once in a while, once in maybe a day, or once in a particular event is triggered. So you need not have purchased that server and keep that server fully available to you without knowing when that application is going to be executed, right? So your cost will keep going up because you are just holding back that server. So instead of just holding back that server, you just release that and you don't even have to purchase that server. And whenever there is a need, whenever there is a event trigger, at that time, the application that you generated will just go execute without even server and complete the job and come back. So in that way, you don't have to really go and obtain the server, no need to pay for holding back the server, and you will be charged based on number of events that triggered that particular program. So this architecture is serverless architecture, right? So your program again will be bundled. Everything will be bundled. I mean, the runtime and all the libraries and the tools that are required to execute the program will be bundled, and it will be given to serverless. So then, how is it different from containers, right? So it is based on the situation in which the application will be designed for, right? So, for example, you just have a serverless design for event. For example, the user uploads its picture, and as soon as that picture is uploaded, your application will have to re-image it and keep it in another place. So that's more like an event, right? So the user uploading his or her photo is an event. So based on that event, the application will have to run. So that's a typical scenario for a serverless architecture, right? So that's a main difference in the sense if you want to go for containers you put your microservices blocks inside the containers, and you can just keep moving the container from one environment to another environment. For example, if you want to move from development region to testing region, pre-prod and production. So just a seamless movement of your code from one region to another region will be possible by containerization. Or if you want to move from on-prem to cloud and cloud to on-prem is possible with containerization. But serverless, as I mentioned, it is used in a different scenario. And also serverless, as I mentioned before, it is possible only in cloud applications, and it is not possible with the on-prem solution. But containers can be used both in clouds as well as in on-prem solutions. So that's a major difference between this and serverless architecture and containerization. Yeah, so when you want to design cloud first application, right? So you need to be aware of these topics, whatever I just covered. So that is containers, orchestration, and serverless. So containers hold all these microservices, and wherever you want to implement, it will be handy. And Kubernetes, which is the orchestrator for containers, will help you manage these containers. And serverless, without without procuring the servers, whenever that event happens, your application will get executed, and your charges on using those applications will go down, or it will be based on the number of triggers that you have. So these are the topics that I want to cover in today's topic, and I hope they are useful to you. In case if you have any questions, please leave me the comments, and thanks for watching.